Right, so here's our question here. We're going to look at two particular vectors, 3i minus 5j, and b, which is minus 2i plus j. And the first thing they want us to do is find a plus b. Now, when we approach vectors, we can approach them algebraically or visually. It's quite easy to do them algebraically. You can actually just treat them like algebra in terms of the like terms that we have. So you've got these two horizontal components and these two vertical components. And anytime you want to add vectors together, you just have to add their respective horizontal and vertical components, right? So I've got 3 plus minus 2, or that's just minus 3 plus minus 2 is just 1. So that's just going to be I, just like an algebra. You just write it like a single variable like itself. And then we've got minus 5 plus 1. We've got minus 5j plus j, so that's minus 5 plus 1. That would be negative 4j. Right? And that's the vector that we create. So that's a plus b. Now, I'm a very visual person, so I just want to briefly show you the visual representation. I'm going to go into what this means a bit more later on, but just to show you quickly, we've got our vector here, a, so a for green, apple green maybe. So you've got that vector there. You can see it's at the coordinate 3, negative 5, so it's an arrow pointing that direction. And you've also got b here, b for blue. That makes a bit more sense. So negative 2, 1, and it's pointing in that position over here. And if we add them together visually, it's going to look like this. When you get blue and green together, you get yellow from memory, from my visual arts. So that's what that's going to look like. What else can we kind of do with this? Well, in our basics component, we can also look at subtracting and multiplications by a scalar. So I'm going to do both of those in this question. So we want to find 2b minus a. And so remember I said when you have a multiplication by a scalar, all you're doing is you're multiplying a number by that vector there. The end result though is still like just a normal vector that you're getting, right? So you're still getting a vector at the end, just like we got here. This is like another vector here, right? So if I wanted to do 2b minus a, all I'm doing is I'm doubling the horizontal and vertical components here. So if you wanted to write it out, you don't have to, but you could write it out like this. And if we're subtracting a, I'm writing it like this. Right, so you see, I didn't write it out for this one here, but I'm just writing it out to show you clearly what's going on here. You are doubling these components. What the heck? Why did I write it like that? So if I was to write exactly what I'm doing, it would look something like this. So I'm doubling this vector here. And then I'm subtracting the vector a. So it's 3i minus 5j. Okay? And so just like expanding brackets almost, that's how you can treat this. So you're doubling these components inside here. And then when I take away anything inside here, we're going to swap any signs that we have, right? And you can see why it's very similar to just like expanding brackets out, because now you can kind of collect like terms. So I'm going to get these horizontal components together, so minus 7i, and then it looks like plus 7j.